Alright, today let's solve another Laplace transform. Right off the bat, you can see that this is a very complicated situation. So, rest assured, the more complicated it looks, the easier it actually is. So let's go ahead and start off with partial fraction. So we know that s minus 2 squared, we can split them into two different terms, which is a with s minus 2 plus b over s minus 2 squared. S squared minus 2s plus 4, unfortunately it does not it's not able to be simplified further. It's just a quadratic formula or expression. So in this case we have to leave it as cs plus d over s squared minus 2s plus 2. But now you might be asking, what do I do with this little guy? Remember, whenever for Laplace transform you see an exponential to the power of negative s or s, whatever it is, but usually it's negative s, or rather should I say a negative term, then you know this has something to do with unit step. So you know for sure that this has something to do with t minus 1. But we'll touch on that later. Let's go ahead and solve the green part first. So simplify everything. We have s squared minus 4s plus 2 equals to a times s minus 2 s squared minus 2s plus 2 plus b over s squared minus 2s plus 2. I'm going to separate the c and the d to make it much easier to be seen. So we have a cs. Alright, for me, I made a lot of careless mistakes, so I'm just going to put the s in a different color to tell myself that there's actually an s over there. Yes, you can put the s into the equation, but it's really up to you. So anyway, s minus 2 squared equals to s squared minus 4s plus 4. And last but not least, I'm going to do the same for the d. So it's s squared minus 4s plus 4. Let's go ahead and find all the terms, shall we? So let's look at the s cubed term first. So the s cubed term on the left hand side is 0 because there is no s cubed term, equals to a plus c. Or maybe let's just go ahead and write down all the terms that we want to find, which is, at the end of the day, is quite straightforward. Right. S squared term, on the left we have a 1. On the right we have s times minus 2s plus minus 2 s squared. You cannot visualize it. This and this, this and this. Alright. So I'm just going to write this shortcut down. So it becomes negative 4a plus b minus 4c plus d. There's one term. Negative 4 equals to 6a minus 2b plus 4c minus 4d. And last but not least, 2 equals to negative 4a plus 2b plus 4d. To make my life a lot simpler for you guys as well, I'm going to label each equation respectively 1, 2, 3, 4. Alright, maybe we can play around a little bit. A equals to negative c. Let's see. Oh, okay. We know that this negative d cancels out this positive d. This negative 2b cancel out this positive 2b. There is no c in the constant term, so we can play around with that. But this doesn't really help us, right? And that's where we use the first term. Alright? So using 1, 3, and 4, I'm just going to do a little bit of shortcut. So with 3 plus 4, okay, so we have negative 4 plus 2 equals to negative 2. That's the left hand side. Now for the right hand side, I'm going to change all my a's to c. So we have negative 6c minus, we know that the b is going to cancel out each other, the d is going to cancel out each other. So let's just cut to the chase and write for c. On the other end, we have negative 4a. And since a is negative c, it becomes positive 4c. Am I right? Yes. Then from here, e equals to 4 plus 4, 8, 8 minus 6, 2c. And since this is the left hand side and this is the right hand side, I know that negative 2 equals to 2c, c equals to negative 1. Alright, so let's go ahead and clear this. So we know that now c equals to negative 1, which means my a is equals to positive 1. Right, what can we solve now? Let's see. Maybe let's try to simplify it even better, okay? So we have a 1 equals to minus 4 plus 4, so we need to cancel out each other. So it becomes a 1 equals to b plus d. Over here we have a minus 4 equals to, we have a 6 minus 4, so it gives me 2 minus 2b minus 4d. Then if I were to make life a lot simpler, this becomes negative 6. Then this guy just move over here. Am I right? And last but not least, we have 6 equals to 2b plus 4d. Wow! I can add these two terms together. No, I can't actually. They will just cancel out each other. Oh, but we do know something, don't we? We know that this just becomes actually we don't know it, do we? Let's see, maybe we can play around with this. So we know that d equals to 1 minus b. So in this case, negative 6 equals to negative 2b minus 4, 1 minus b. Negative 6 equals to negative 6b minus 4. Sorry, minus plus. So negative 6 equals to, no, I'm just gonna write it out, minus 4b plus, so minus 4 plus 4b. So negative 6, bring the 4 over, so negative 2 equals to 2b. So b equals to negative 1, d equals to 2. There we have it. So now let's write down this little guy right here. So I'm just gonna copy and paste. Right. So now we have equals to, a was 1. Was a 1 or c 1? A was 1. Alright. 1 minus 2. B was negative 1. So I changed the positive to negative. Plus, let's just separate the term, shall we? So c was negative 1, right? So negative 1s over s squared minus 2s plus 2. D was 2, right? Yep. So it becomes s squared minus 2s plus 2. Alright, how can we make this a lot better? Okay, let's be real. This first two is very simple. But what about the behind 2? That's where we do, I believe the term is called completing the square. So we first look at s squared minus 2x, okay, plus 2. So we know that this guy can becomes s minus 1 square. And you know, at the back there will be a plus 1, right? Plus 1. Is it plus 1? Yes, a plus 1. Am I missing something? Plus 1 plus 1. Ah, okay, yeah, it's a plus 1 because this equals to s squared minus 2s plus 1 plus 1, which will give me the 2. Yeah, so it's a plus 1. Alright, my brain farted a little bit. So now that we know that this is a valid thing, let's go ahead and rewrite everything, shall we? So we have a 1 minus this minus s over s minus 1, right, and then a plus 2 over s squared minus 2. Sorry, I meant to write it in the new form. Alright, what does this remind you of? Right off the bat, you know that I'm gonna play with the cosine and the sine for these two terms. Because remember, cosine, if I'm not wrong, is something like s over s squared plus 1, right? And then for the sine is alpha over s squared plus alpha. Something like that, yeah. Right? But then, now you know that your s is not just s, it's a s minus 1. So how can we make this better? And you know that this is a 1 or so. Okay, you know what? Let's make the top guy over here a 1. Pretty straightforward, right? Or pretty standard. 1 plus 1. Okay. What should we do? Maybe we can do a minus 1 over here. Why? Because if I were to bracket this up, minus s minus 1 equals to s plus 1. 1 plus 1 give me the 2 that I originally had over here. Am I right? So basically I'm splitting the 2 out. Alright? Because I know that for my cosine, I will be playing around with the s. So I need to make sure that my top is the same as the bottom s. Whereas for my sine, I only need to care about alpha. And since alpha is 1 over here, the top needs to be 1. Yeah, so this is something that people will need to require a little bit more visualization and thinking to be able to detect this. So now that we have detected this, guys, remember this e to the power of negative s. So to remind you, this whole thing times this, right? So now let's go ahead and Laplace inverse each term, shall we? So Laplace inverse term, okay, I'm going to call it term 1, 2, 3, 4. Maybe we can call this a 5, okay? So for Laplace inverse of term 1, I think it's pretty straightforward. We know that it's basically 1 over s e to the power of 2t, and you know that this 1 over s becomes a constant, right? So in the end, it's just going to be this. Sorry, I didn't mean to put the negative. Minus, okay, so same thing, e 2t, right? But then this becomes 1 over s squared. 1 over s squared is just t, am I right? So let's go ahead and erase this let me increase the, okay, then after that, oh wait, this is, sorry, this is term 1, this is term 2. Okay, I'm going to color code it later. Okay, then for this little bugger over here, so Laplace inverse of 3 equals to, remember the term is s, or the term on top was something like s over s squared plus 1 equals to, so we know that this becomes a cosine alpha theta, am I right? But because it's a s minus 1, we need to add a yes, et in front, because e1t. Okay, so it becomes et cosine alpha is 1, so cosine t. And last but not least, for 4, the fourth term, you know, is sine, so let's go ahead and write the sine down first. Alpha is 1, and s minus 1, there we go, et. So let's write all these terms together. Maybe I should color code it just so you guys can see it better. Right, let's add all these together and then we put in the e to the power of negative s. So the Laplace inverse essentially just, oops, I didn't mean to go eraser. Ft equals to term 1 minus term 2 plus term 3 plus term 4. Okay, but remember, because of this guy over here, term 5, we need to make all our t to t minus 1, then we times the whole thing by unit step. So let's go ahead and make the whole thing t minus 1. So ft equals to exponential to t minus 1 minus t exponential to t minus 1 plus t minus 1 cosine t minus 1 plus exponential t minus 1 sine t minus 1. And then we bracket the whole thing times the unit step. But remember, this is just our general solution. What they want us to find is when your t equals to 5 over 4. So when t equals to 5 over 4, your t in this particular case is bigger than 1, which means your unit step got switched on. If your t was less than 1, I can say that the whole function equals to 0 because it haven't been turned on. But since now that it had been turned on, if I were to sub this in, which I'm too lazy to press in a calculator, it should give you about something like 0.31. And there you have it.